So we're given a graph, and we're asked to find the minimum vertical distance between these two functions, as well as the minimum horizontal distance between the two functions. Now, taking a look at this, we should note that wherever we are along the x-axis, the vertical distance between the two functions will be the top function minus the bottom function. Similarly, wherever we are on the y-axis, the difference from, the horizontal distance will equal the x value of this function, the right-hand function, minus the x value of the left-hand function. So the vertical distance can be written, so let's call it v of x, will be equal to 4x plus 2 minus the natural log of x. It'll be the top function minus the bottom function. Now, to find the horizontal distance, h of x, h of y, because we have to write it in terms of y, because we're dealing with the other axis. Let's solve for x in both of these equations. Subtract 2 from both sides. Y minus 2 equals 4x. Divide by 4. X equals y minus 2 over 4. Y equals the natural log of x. E raised to the power of both sides. We'll get x is equal to e to the y, because e raised to the natural log cancels out. So now we can write that h of x is equal to e to the power of y minus, and I'm going to distribute here, y to the fourth, y over 4 plus 2/4. Now, to find the minimum vertical distance or the minimum horizontal distance, we're going to find the minimum value of these functions. To do so, we're going to use the second derivative test. So first, we're going to find the first derivative. Let's just focus on the vertical distance. So v prime of x is equal to 4 minus 1 over x. Because the derivative of 4x is 4, the derivative of 2 is 0 because it's constant, and the derivative of negative natural log of x is negative 1 over x. Now let's set v prime of x equal to 0 and solve for x. X will equal to 1/4 because 1 divided by 1/4 will equal to 4. 4 minus 4 is 0. 0 equals 0. So if v of x has an extreme value, it must be at x equals 1/4. Now, we're going to find the second derivative, and we'll plug in x equals 1/4 into this second derivative. That's why it's called the second derivative test. We're going to test the critical point on the second derivative. So first, let's find the second derivative. It's going to be equal to 1 over x squared. And let's plug in x equals 1/4. So v double prime of 1/4 will equal 1 over 1/4 squared, which will equal 16, which is positive, which means that there is a minimum here because of the rate at which the first derivative is changing, is increasing. So that means that it's continuously sloping upwards, which means that the critical point is a minimum value. So to find what that minimum value is, the minimum value of the function, we plug x equals 1/4 into the original function v of x. So we will get 4 times 1/4 plus 2 minus the natural log of 1/4, which will equal 3 minus the natural log of 1 over 4. And remember, the natural log, let's say the natural log of 1 over 4 is equal to the natural log of 4 to the negative 1. And we can pull out that negative 1. So that will be equal to 3 plus the natural log of 4. So this is the solution for the minimum vertical distance. Now, we're going to use this same method, the second derivative test, to find the minimum for the horizontal distance. So let's find the first derivative. H prime of y is equal to e to the y minus 1 over 4, because the derivative of e to the y is e to the y. The derivative of negative y over 4 is negative 1 over 4. And the derivative of 2/4 is 0 because it's constant. So let's set this equal to 0. 0 is equal to e to the power of y minus 1/4. Adding 1/4 to both sides, we get 1/4 is equal to e to the y. Taking the natural log of both sides, we get the natural log of 1 over 4 is equal to y. Because the natural log raised to the e cancels each other out. So if h of y has an extreme value, it must be it where y equals the natural log of 1 over 4. So let's take the second derivative of h of y. So h double prime of y will be equal to e to the y. And let's plug in y equals the natural log of 1 over 4 into the second derivative. We're doing the second derivative test. So e raised to the natural log of 1 over 4 will be equal to 1 over 4. This is positive, therefore there is a minimum here. Okay, now we can find that minimum value by plugging in y equals the natural log of 1 over 4 into the original equation, which will equal e to the natural log of 1 over 4 minus the natural log of 1 over 4 divided by 4 plus 2/4, which will equal 1 over 4 plus the natural log of 4 divided by 4, again because the natural log of 1/4 is the same as the natural log of 4 raised to the power of negative 1, so you can bring that negative 1 out. Plus 2/4, and this will be equal to 3/4 plus the natural log of 4 divided by 4. And that's the solution for the minimum horizontal distance for this function. So there you go.